Imagine standing at the edge of a volcano, feeling the ground tremble beneath your feet. The air grows thick with sulfur. Deep below, millions of tons of molten rock are building pressure, ready to explode with the force of thousands of nuclear bombs. Now imagine this. What if we could stop it? What if humanity had the power to prevent one of nature's most devastating forces from unleashing its fury? Welcome to Imagine This, where we explore the impossible and ask the questions that push the boundaries of science and imagination. Today, we're diving deep into the heart of the Earth to answer one explosive question. Could we actually stop a volcanic eruption? The answer might surprise you, because while it sounds like pure science fiction, scientists have been studying this very possibility. And what they've discovered is both fascinating and terrifying. Before we talk about stopping a volcano, we need to understand exactly what we're up against. And trust me, it's more powerful than you might think. A volcanic eruption isn't just a mountain spitting out lava. It's one of the most intense releases of energy on our planet. When Mount St. Helens erupted in 1980, it released energy equivalent to 24 megatons of TNT. That's roughly 1,600 times more powerful than the atomic bomb dropped on Hiroshima. But here's where it gets truly mind-blowing. Mount St. Helens was actually a relatively small eruption. The 1815 eruption of Mount Tambora in Indonesia released about 100 times more energy. It ejected so much ash and sulfur dioxide into the atmosphere that it caused global temperatures to drop, leading to what became known as the Year Without a Summer in 1816. Crops failed worldwide. Snow fell in July in New England. Famine spread across Europe. And even Tambora pales in comparison to supervolcano eruptions. The Yellowstone supervolcano, sitting quietly beneath Wyoming, has erupted 3 times in the past 2 million years. Each eruption was approximately 1,000 times more powerful than Mount St. Helens. The last one, 640,000 years ago, covered half of North America in ash, up to 3 feet deep. So what creates this incredible power? It all comes down to magma, molten rock that sits in chambers miles beneath the Earth's surface. This magma contains dissolved gases, mainly water vapor, carbon dioxide, and sulfur dioxide. As the magma rises toward the surface, the pressure decreases, and these gases come out of solution, like opening a shaken soda bottle, except on a geological scale. When the pressure becomes too great, the volcano erupts, sending gas, ash, and lava exploding outward at speeds up to 450 miles per hour and temperatures exceeding 1,800 degrees Fahrenheit. That's what we're talking about stopping. The question is it even possible? Humans have actually tried to control volcanic activity before, and some of the attempts have been, well, let's just say, ambitious. In 1935, when the Mauna Loa volcano in Hawaii erupted, lava flows threatened the city of Hilo. The U.S. Army Air Corps had an idea. What if they bombed the volcano? The logic was that bombs could either divert the lava flow or solidify it by disrupting the channels through which it flowed. They dropped 2,600-pound bombs on the lava flows. The result? Practically nothing. The lava barely changed course. It turns out that dropping explosives on flowing lava is about as effective as throwing ice cubes at a wildfire. But that hasn't stopped people from proposing even wilder ideas over the years. Some have suggested using nuclear weapons to either release pressure gradually or seal volcanic vents. There are multiple problems with this approach. First, the explosion would need to be precisely calibrated. Too small, and it does nothing. Too large, and you might trigger the very eruption you're trying to prevent. Second, you'd be contaminating the area with radioactive fallout. And third, the magma chamber could be dozens of miles wide and several miles deep. One nuclear bomb wouldn't even make a dent. Others have proposed diverting lava flows using barriers or channels. This has actually been tried with some limited success in Iceland and Hawaii. In 1973, during the Eldfell eruption in Iceland, firefighters sprayed seawater on the advancing lava for months, successfully cooling and hardening it enough to protect the harbor. But here's the catch. This only works on lava that's already flowing. It does absolutely nothing to prevent the eruption itself. So bombing doesn't work. Nuking is insane. Barriers only help after the fact. What else is there? This is where scientists started thinking differently. Instead of trying to fight the eruption directly, what if we could prevent the conditions that cause eruptions in the first place? Here's where things get interesting. Scientists have identified one potentially viable method: cooling the magma chamber. The idea is surprisingly straightforward in concept. If you could remove enough heat from a magma chamber, you could prevent the magma from melting and rising. Without rising magma, there's no eruption. So how would you cool something that's several miles underground and hotter than molten metal? Water. In 2017, a NASA study proposed an audacious plan for the Yellowstone supervolcano. They suggested drilling down 10 kilometers, about 6 miles, into the magma chamber and pumping high-pressure water through the system. The water would absorb heat from the magma and return to the surface as superheated steam, which could actually be used to generate geothermal power. According to their calculations, this system could remove around 35% of the heat from the magma chamber. Over the course of tens of thousands of years, this could theoretically neutralize the threat of eruption entirely. And as a bonus, the process would generate enough electricity to power the surrounding region. Sounds perfect, right? Well, not exactly. There are some massive challenges and risks with this approach. First, drilling 10 kilometers down through solid rock is incredibly difficult and expensive. We're talking about a project that would cost billions of dollars and take decades to complete. Second, you'd need to drill through the very volcano you're trying to calm down. There's a serious risk that drilling could fracture the rock above the magma chamber, potentially triggering the eruption you're trying to prevent. It's like trying to defuse a bomb while hitting it with a hammer. Third, even if you successfully drilled down and started pumping water, the cooling process would be incredibly slow. We're talking about geological timescales, thousands or even tens of thousands of years. That's great for preventing eruptions in the distant future, but it won't help if a volcano shows signs of erupting next year. And finally, there's the question of whether we should even try. Volcanoes are a natural part of Earth's geological cycle. They help regulate the planet's temperature, create new land, and contribute to soil fertility. By interfering with this process, we might cause unintended consequences we can't even predict. But let's imagine we solved all these problems. Let's say we had the technology, the money, and the time. Could we actually do it? Here's the truth. We're probably decades, if not centuries, away from being able to stop a volcanic eruption. But we've gotten remarkably good at something else: predicting them. Modern volcanology has developed an impressive array of tools to monitor volcanic activity and give us warning before an eruption occurs. Seismometers detect the tiny earthquakes that occur when magma moves underground. GPS sensors measure ground deformation. Even changes as small as a few millimeters can indicate that magma is rising. Gas sensors monitor the release of volcanic gases, which increase dramatically before eruptions, and satellite imagery can detect changes in temperature and ground level from space. By combining all these monitoring techniques, scientists can often predict eruptions days, weeks, or even months in advance. This gives authorities time to evacuate populations and prepare for the disaster. The 1991 eruption of Mount Pinatubo in the Philippines is a perfect example. Monitoring equipment detected warning signs, and authorities evacuated 60,000 people from the danger zone. When the volcano erupted, one of the largest eruptions of the 20th century, an estimated 5,000 lives were saved by the evacuation. This is our most realistic stopping mechanism right now. We can't prevent the eruption, but we can get people out of harm's way before it happens. Scientists are also working on more sophisticated prediction methods. Machine learning algorithms are being trained on decades of volcanic data to identify patterns that precede eruptions. Some researchers are even experimenting with acoustic sensors that can listen to the sound of magma moving underground, potentially giving even earlier warnings. But prediction isn't prevention, and for densely populated areas near major volcanoes, like Naples, Italy, which sits next to Mount Vesuvius, or the cities surrounding Mount Rainier in Washington state, even successful evacuations would mean abandoning homes, businesses, and entire communities, possibly forever. So the question remains, will we ever be able to truly stop an eruption? Let's imagine the future. Let's say humanity continues advancing for another 100 or 200 years. What might become possible? One fascinating concept involves using advanced materials to contain volcanic pressure. Imagine injecting self-solidifying materials into rock fractures around a magma chamber, creating an artificial containment system that could withstand enormous pressure and heat. These materials don't exist yet, but nanotechnology and advanced ceramics might make them possible someday. Another idea involves precision pressure release. Instead of letting pressure build to catastrophic levels, we could potentially drill small, controlled release valves that allow gas and minimal amounts of magma to escape gradually. Think of it like releasing air from an overinflated tire before it explodes. The challenge would be doing this without triggering a larger eruption, an incredibly delicate operation. Some scientists have even proposed using artificial intelligence and quantum computing to model magma chamber dynamics with such precision that we could predict exactly where and when to intervene. With that level of understanding, we might be able to trigger micro-eruptions at safe locations, releasing pressure before it builds to dangerous levels. There's also the possibility of energy extraction becoming so efficient that cooling magma chambers becomes economically viable. If we could generate massive amounts of clean energy while simultaneously preventing eruptions, suddenly the motivation to develop this technology would skyrocket. But here's something most people don't consider. Maybe we shouldn't stop all eruptions even if we could. Volcanic eruptions, while devastating, also serve important functions. They recycle minerals from deep within the earth back to the surface. They create incredibly fertile soil. Some of the world's most productive farmland exists on volcanic soil. They even play a role in regulating Earth's climate over geological timescales. The question might not be, can we stop eruptions? But rather, which eruptions should we stop and which should we allow? Imagine a future where we have a global volcanic management system. Small eruptions in remote areas proceed naturally, but threats to major population centers like Naples, Tokyo, or Seattle are carefully managed and diffused over decades using advanced cooling and pressure release technologies. It sounds like science fiction, but then again, so did flying to the moon, editing human genes, and creating artificial intelligence. Yet we've done all of those things. So, what if we could stop a volcanic eruption? The honest answer is, we can't. Not yet. Not with our current technology. The forces involved are simply too powerful, too deep, and too complex for us to control. But that doesn't mean we never will. History shows us that humans have an incredible ability to solve problems that seem impossible. We've conquered diseases, split the atom, and sent robots to other planets. The question isn't whether we'll eventually develop the technology to prevent volcanic eruptions. It's when and at what cost. The real question might be whether we should. Volcanoes have shaped our planet for billions of years. They've created the continents we live on, the atmosphere we breathe, and some of the most beautiful landscapes on Earth. They're destructive, yes, but they're also creative forces. Perhaps the answer isn't to stop volcanoes entirely, but to learn to live with them more safely, better monitoring, better evacuation systems, better urban planning that keeps people away from the most dangerous zones, and maybe someday selective intervention for the most dangerous volcanoes threatening the most people. One thing is certain, as climate change intensifies and populations grow, the stakes are getting higher. Millions of people live within range of potentially active volcanoes. The need for solutions, whether through prevention, prediction, or adaptation, is only going to increase. So the next time you see a volcano, whether it's in a documentary, in person, or on a map, remember, beneath that mountain lies one of nature's most powerful forces. We've learned to harness wind, water, and even atoms. Could volcanoes be next? What do you think? Could we ever stop a volcanic eruption? Should we even try? Let me know in the comments below. And if you enjoyed exploring this impossible question, subscribe to Imagine This for more deep dives into the scenarios that make you stop and think. Until next time, keep imagining.